engine, edit. Main article, Turbo Union RB199. Britain considered the selection of Rolls-Royce to develop the advanced engine for the MRCA to be essential, and was strongly opposed to adopting an engine from an American manufacturer, to the point where the UK might have withdrawn over the issue. In September 1969, Rolls-Royce RB199 engine was selected to power the MRCA. One advantage over the US competition was that a technology transfer between the partner nations had been agreed. The engine was to be developed and manufactured by a joint company, Turbo Union. The program was delayed by Rolls-Royce's entry into receivership in 1971. However, the nature of the multinational collaboration process helped avoid major disruption of the Tornado program. Research from the supersonic airliner Concorde contributed to the development and final design of the RB199 and of the engine control units. RB199 on static display at the Royal Air Force Museum, Cosford. To operate efficiently across a wide range of conditions and speeds up to Mach 2, the RB199 and several other engines make use of variable intake ramps to control the airflow. The hydraulic system is pressurized by siphoning power from both or either operational engine. The hydraulics are completely contained within the airframe rather than integrating with the engine to improve safety and maintainability. In case of double engine, or double generator, failure, the Tornado has a single-use battery capable of operating the fuel pump and hydraulics for up to 13 minutes. Relatively rarely among fighter aircraft, the RB199 is fitted with thrust reversers to decrease the distance required to land safely. To fully deploy the thrust reverser during landings, the yaw damper is connected to the steering of the nose wheel to provide greater stability. In August 1974, the first RB199 powered flight of a prototype Tornado occurred and the engine completed its qualification tests in late 1978. The final production standard engine met both reliability and performance standards, though the development cost had been higher than predicted, in part due to the ambitious performance requirements. At the time of the Tornado's introduction to service, the turbine blades of the engine suffered from a shorter lifespan than desired, which was rectified by the implementation of design revisions upon early production engines. Several uprated engines were developed and used on both the majority of Tornado ADVs and Germany's Tornado ECRs. The DECU, Digital Engine Control Unit, is the current engine control unit for RB199 engines, superseding the analog MECU, Main Engine Control Unit, also known as Q. Upgrades, edit. Being designed for low-level operations, the Tornado required modification to perform in medium-level operations that the RAF adopted in the 1990s. The RAF's GR1 fleet was extensively remanufactured as Tornado GR4S. Upgrades on Tornado GR4S included a forward-looking infrared, a wide-angle HUD, head-up display, improved cockpit displays, NVG, night vision devices, capabilities, new avionics, and a global positioning system, GPS, receiver. The upgrade eased the integration of new weapons and sensors which were purchased in parallel, including the Storm Shadow cruise missile, the Brimstone anti-tank missile, Paveway 3 laser-guided bombs and the Raptor reconnaissance pod. The first flight of a Tornado GR4 was on the 4th of April, 1997. The RAF accepted its first delivery on the 31st of October, 1997 and deliveries were completed in 2003. In 2005, the ASIF opted to have their Tornado IDSs undergo a series of upgrades to become equivalent to the RAF's GR4 configuration. On the 21st of December, 2007, BAE signed a £210 million contract for CUSP, the Capability Upgrade Strategy, pilot. This project would see IFGR-4/4 improved in 2 phases, starting with the integration of the Paveway 4 bomb and a communications upgrade, followed by a new tactical data link in Phase B. Beginning in 2000, German IDs and ECR Tornadoes received the Aster-1 avionics system software Tornado in ADA upgrade. Aster-1 involved a replacement weapons computer, new GPS and laser inertial navigation systems. The new computer allowed the integration of the HARM-3, HARM-0 Block 4/V and Taurus kept 350 missiles, the Raphael Lightning II laser designator pod and GBU-24 Paveway 3 laser-guided bombs. The Aster-2 upgrade began in 2005. Primarily consisting of several new digital avionics systems and a new ECM suite. These upgrades are to be only applied to 85 Tornadoes, 20 ECRs and 65 IDSs, as the Tornado is being replaced in part by the Eurofighter Typhoon. The Aster-3 upgrade program, started in 2008, will introduce support for the laser-targeted Joint Direct Attack munition along with further software changes. In January 2016, Bild newspaper stated that the newest upgrade of the Aster suite to version 3.1, which includes color multifunctional LCD screens in place of monochrome CRT displays, is interfering with helmet-mounted night vision optical displays worn by pilots, rendering German Tornado bombers deployed to Syria useless for night missions. The Defense Ministry admitted that bright cockpit lights could be a distraction for pilots, and said that the solution will be implemented in a few weeks, but denied the need to fly night missions in Syria. The TV tab displays are used for route planning, the forward-looking infrared, flow, sensors, targeting pods such as TILD, thermal imaging and laser designator, and CLDP, convertible laser designator pod. The original MRCA TV tab do navigation display, part number V22.498.90, has a green CRT as the picture source. The original price for one CRT display version was €33,852.64. Due to the light environment, the picture tube was pushed to the limit due to the high brightness levels causing wear of the picture tube. An active matrix liquid crystal displays, AMOLED, drop-fit replacement with a digital screen TV tab, NSN 5895-99-597-1323, was developed to replace the old wear-sensitive CRT versions. The CRT versions are mainly recognizable by the 2 white domes at the top of the display containing the light sensors for automatic brightness regulation and the white buttons. The newer digital version is mainly recognizable by the black buttons with big white dots on them. The replacement AMOLED version has a color display instead of the original green monochrome display. A new feature is that the AMOLED has a bezel that reduces the angle of view. The main goal of the AMOLED upgrade was the intended significant reduction in life cycle costs. But it's said that the newer AMOLED version failed rather quickly due to the more sensitive and complex digital electronics compared to the much simpler design of the original CRT display. The old and newer version are a masterpiece of state-of-the-art engineering and both are very well built. For example, there's a diagnostic connector at the back panel for quick troubleshooting. The display unit is eventually a rather dumb device. The original display unit is just a display and a keypad. To show a picture, the separate video signal, vertical and horizontal synchronization signals have to be fed into the display unit since there's no internal electronics for synchronization separation of the video signal. The additional waveform generator, WFG, is needed to create the desired images for use in the airplane. To power the display unit, a three-phase 115 VAC 400 Hz including neutral and a 28 VDC signal have to be supplied to the display unit. The CRT version has a low-voltage power supply, LVPS, for creating the needed low-voltage signals. There's also a high-voltage power supply, HVPS, for creating the desired high voltage for the CRT picture tube. Since the newer AMOCT has no CRT picture tube, the high voltages are not needed and the mechanical and electrical design is completely different except for the connections, mounting points and functionality. The newer AMOCT version only needs 28 VDC for functionality. But since a drop-fit replacement is mandatory, the AMOCT version has a built-in three-phase 115 VAC 400 Hz conversion to 28 VDC. By removing the rear three-phase conversion power supply plug-in board and applying 28 VDC, BAE Systems announced that, in December 2013, it had test-flown a Tornado equipped with parts made by 3D printing. The parts included a protective cover for the radio, a landing gear guard and air intake door support struts. The test demonstrated the feasibility of making replacement parts quickly and cheaply at the airbase hosting the Tornado. The company claimed that, with some costing less than £100 to make, 3D printing of parts had saved more than £300,000 which potentially could reach more than £1.2 million by 2017. Operational history, edit. German Air Force, Luftwaffe, edit. The first Tornado prototype made its first flight on the 14th of August, 1974 from Ingolstadt-Maching Airport, in West Germany. Deliveries of production Tornadoes began on the 27th of July, 1979. The total number of Tornadoes delivered to the German Air Force was 247, including 35 ECR variants. Originally Tornadoes equipped 5 fighter bomber wings, Chestschwede, with 1 tactical conversion unit and 4 frontline wings, replacing the Lockheed F-104 Starfighter. When one of the 2 Tornado wings of the German Navy was disbanded in 1994, its aircraft were used to re-equip a Luftwaffe's reconnaissance wing formerly equipped with McDonnell Douglas RF-4E Phantoms. 14 German Tornadoes undertook combat operations as a part of NATO's campaign during the Bosnian War. The Tornadoes, operating from Piacenza, Italy, flew reconnaissance missions to survey damage inflicted by previous strikes and to scout new targets. These reconnaissance missions were reportedly responsible for a significant improvement in target selection throughout the campaign. In 1999, German Tornadoes participated in Operation Allied Force, NATO airstrikes against the Federal Republic of Yugoslavia during the Kosovo War. This was Germany's first offensive air mission since World War II. The ECR aircraft escorted various Allies' aircraft while carrying several AGM-88 HARM missiles to counter attempted use of radar against the Allied aircraft. During the Kosovo hostilities, Germany's ID's Tornadoes routinely conducted reconnaissance flights to identify both enemy ground forces and civilian refugees within Yugoslavia. The German Tornadoes flew 2,108 hours and 446 sorties, firing 236 HARM missiles at hostile targets. A Luftwaffe Tornado 44 plus 80 of Jagbomber Chestschwede 31 taking off from Eielson Air Force Base, Alaska, in 2004. In June 2007, a pair of Luftwaffe Tornadoes flew reconnaissance missions over an anti-globalization demonstration during the 33rd G8 summit in Heiligendamm. Following the mission, the German Defense Ministry admitted one aircraft had broken the minimum flying altitude and that mistakes were made in the handling of security of the summit. In 2007, a detachment of 6 Tornadoes of the Aufklärungsgeschwader 51 Immelman, 51st Reconnaissance Wing, were deployed to Mazar-i-Sharif, northern Afghanistan, to support NATO forces. The decision to send Tornadoes to Afghanistan was controversial. One political party launched an unsuccessful legal bid to block the deployment as unconstitutional. In support of the Afghanistan mission, improvements in the Tornado's reconnaissance equipment were accelerated, enhancing the Tornado's ability to detect hidden improvised explosive devices, IEDs. The German Tornadoes were withdrawn from Afghanistan in November 2010. Defense cuts announced in March 2003 resulted in the decision to retire 90 Tornadoes from service with the Luftwaffe. This led to a reduction in its Tornado strength to 4 wings by September 2005. On the 13th of January 2004, the then German Defense Minister Peter Struck announced further major changes to the German armed forces. A major part of this announcement was the plan to cut the German fighter fleet from 426 in early 2004 to 265 by 2015. The German Tornado force was to be reduced to 85, with the type expected to remain in service with the Luftwaffe until 2025. The aircraft being retained have been undergoing a service life extension program. Currently, the Luftwaffe operates Tornadoes with tactical wings Taktisches Luftwaffengeschwader 33 in Cochem/Bucher Air Base, Rhineland-Palatinate, and with Taktisches Luftwaffengeschwader 51 im Elmen in Jagel, Schleswig-Holstein. German Tornado aircrew training took place at Holloman Air Force Base in New Mexico, U.S. from January 1996 at the Taktisches Ausbildungskommando der Luftwaffe USA, TACT-OSP du LW USA Tactical Training Command of the Luftwaffe USA, which was responsible for training both German F-4 Phantom and Tornado crews. In 1999 the training command was renamed as Fliegerisches Ausbildungszentrum der Luftwaffe, Flughausbau Luftwaffe Training Center. In March 2015, Defense Minister Ursula von der Leyen decided to continue this training in Germany. In September 2017, flight training in Holloman for the Tornado was discontinued and transferred to Taktischen Luftwaffengeschwader 51 in Jagel, with the U.S. location command dissolved in 2019. In April 2020, it was reported that the German Defense Ministry planned to replace its Tornado aircraft with a purchase of 30 Boeing F/A-18E/F Super Hornets, 15 EA-18G Growlers, and 55 Eurofighter Typhoons. The Super Hornet was selected due to its compatibility with nuclear weapons and availability of an electronic attack version. In March 2020, the Super Hornet was not certified for the B-61 nuclear bombs, but Dan Gillian, head of Boeing's Super Hornet program, previously stated, "We certainly think that we, working with the US government, can meet the German requirements there on the required timeline." In 2021, Airbus offered to replace Luftwaffe's 90 aging Tornado interdiction and strike IDs and electronic combat reconnaissance ECR aircraft with 85 new Eurofighter Tranche 5 standard from 2030. In 2022, the German Defense Ministry announced that 35 Lockheed Martin F-35 Lightning IIS will replace the Tornado fleet for nuclear sharing instead of the discussed 30 Boeing Super Hornets. German Navy, Marineflieger, edit. In addition to the order made by the Luftwaffe, the German Navy's Marineflieger also received 112 of the ID's variant in the anti-shipping and marine reconnaissance roles, again replacing the Starfighter. These Tornadoes equipped 2 wings, each with a nominal strength of 48 aircraft. The principal anti-ship weapon was the AS-34 Qumran anti-ship missile, which were initially supplemented by unguided bombs and BL-755 cluster munitions, and later by AGM-88 HARM anti-radar missiles. Pods fitted with panoramic optical cameras and an infrared line scan were carried for the reconnaissance mission. The end of the Cold War and the signing of the CFE Treaty led Germany to reduce the size of its armed forces, including the number of combat aircraft. To meet this need, one of the Marineflieger's Tornado wings was disbanded on the 1st of January 1994. Its aircraft replaced the Phantoms of a Luftwaffe reconnaissance wing. The second wing was enlarged and continued in the anti-shipping, reconnaissance and anti-radar roles until it was disbanded in 2005 with its aircraft and duties passed on to the Luftwaffe. Italian Air Force, Aeronautica Militare, edit. The first Italian prototype made its maiden flight on the 5th of December 1975 from Turin. The Aeronautica Militare received 100 Tornado IDSs, known as the A200 in Italian service. 16 A200s were subsequently converted to the ECR configuration. The first Italian Tornado ECR, known as the EA200, was delivered on the 27th of February 1998. As a stopgap measure for 10 years, the Aeronautica Militare additionally operated 24 Tornado ADVs in the air defense role, which were leased from the RAF to cover the service gap between the retirement of the Lockheed F-104 Starfighter and the introduction of the Eurofighter Typhoon. 2 Italian A200 Tornadoes participating in NATO exercise Dragon Hammer, May 1987. Italian Tornadoes, along with RAF Tornadoes, took part in the First Gulf War in 1991. Operation Locusta saw 8 Tornado IDs interdictors deployed from Gioia del Colle, Italy, to Al Dhafra, Abu Dhabi, as part of Italy's contribution to the coalition. During the conflict, 1 aircraft was lost to Iraqi anti-aircraft fire. The pilots ejected safely and were captured by Iraqi forces. A total of 22 Italian Tornadoes were deployed in the NATO-organized Operation Allied Force over Kosovo in 1999. The A200s served in the bombing role while the EA200s patrolled the combat region, acting to suppress enemy anti-aircraft radars, firing 115 AGM-88 HARM missiles. In 2000, with delays to the Eurofighter, the Aeronautica Militare began a search for another interim fighter. While the Tornado was considered, any long-term extension to the lease would have involved upgrade to RAF CSP standard and thus was not considered cost-effective. In February 2001, Italy announced its arrangement to lease 35 F-16s from the United States under the Peace Caesar program. The Aeronautica Militare returned its Tornado ADVs to the RAF, with the final aircraft arriving at RAF St. Athan on the 7th of December 2004. 1 aircraft was retained for static display purposes at the Italian Air Force Museum. In July 2002, Italy signed a contract with the Tornado Management Agency, NETMA, and Panavia for the upgrading of 18 A200s, the first of which was received in 2003. The upgrade introduced improved navigation systems, integrated GPS and laser INS, and the ability to carry new weapons, including the Storm Shadow cruise missile, Joint Direct Attack Munition and Pave Way 3 laser-guided bombs. In response to anticipated violence during the 2010 Afghanistan elections, Italy, along with several other nations, increased its military commitment in Afghanistan, dispatching 4 A200 Tornadoes to the region. Italy has opted to extend the Tornado's service life at the expense of alternative ground attack aircraft such as the AMX International AMX, In 2010 a major upgrade and life extension program was initiated to provide new digital displays, Link 16 communications capability, night vision goggles compatibility, and several other upgrades. In the long term, it is planned to replace the Tornado IDs/ECR fleet in Italian service with the Lockheed Martin F-35 Lightning II, with the final Italian Tornado scheduled to be phased out in 2025. The Aeronautica Milita received its first of an eventual 15 upgraded Tornado EA-200S on the 15th of June, 2013. Italian Tornado A-200 and EA-200 aircraft participated in the enforcement of a UN no-fly zone during the 2011 military intervention in Libya. Various coalition aircraft operated from bases in Italy, including RAF Tornadoes. Italian military aircraft delivered a combined 710 guided bombs and missiles during the strikes against Libyan targets. Of these, Aeronautica Milita Tornadoes and AMX fighter bombers released 550 guided bombs and missiles, and Italian Navy AV-8BS delivered 160 guided bombs. Italian Tornadoes launched 20 to 30 Storm Shadow cruise missiles, with the rest consisting of paveway and jam guided bombs. On the 19th of August, 2014, two Aeronautica Milita Tornadoes collided in mid-air during a training mission near Ascoli. On the 14th of November, 2014, Italy announced it was sending 4 Tornado aircraft with 135 support staff to Ahmed Al-Jaber Air Base and to 2 other bases in Kuwait in participation of coalition operations against the Islamic State. The 4 aircraft will be used for reconnaissance missions only. In October 2018, it was announced that the EA-200 Tornado had successfully completed operational testing of the AGM-8080 providing capabilities of an expanded target set, counter-shutdown capability, advanced signals processing for improved detection and locating, geographic specificity, and a weapon impact assessment broadcast capability. Royal Air Force, Edit. Tornado GR1ZA613 of No. 27 Squadron arriving at Riyadh, July 1983. Nicknamed the Tonka by the British, their first prototype, XX946, made its maiden flight on the 30th of October 1974 from Backwater. The first full production Tornado GR1, ZA319, flew on the 10th of July 1979 from Wharton. The first RAF Tornadoes, ZA320 and ZA322, were delivered to the TTTE at RAF Cottesmore on the 1st of July 1980. Crew that qualified from the TTTE went on to the Tornado Weapons Conversion Unit, TWCU, which formed on the 1st of August 1981 at RAF Honington, before being posted to a frontline squadron. Number 9B Squadron became the first frontline squadron in the world to operate the Tornado when it reformed on the 1st of June 1982, having received its first Tornado GR1ZA586 on the 6th of January 1982. Number 9B Squadron was declared strike combat ready to the Supreme Allied Commander Europe, CESA, in January 1983. 2 more squadrons were formed at RAF Marham in 1983, number 617 Squadron on the 1st of January and number 27 Squadron on the 12th of August. The first RAF Tornado GR1 loss was on the 27th of September 1983 when ZA586 suffered complete electrical failure and crashed. Navigator FLT Lieutenant Nigel Nichols ejected, but the pilot SQNLDR Michael Stevens died in the crash after ordering ejection. In January 1984, the TWCU became number 45, Reserve, Squadron. RAF Germany, RAF began receiving tornadoes after the formation of number 15, designate, squadron on the 1st of September, 1983 at IF La Bruche, followed by number 16, designate, squadron in January, 1984, who were both Blackburn Buccaneer squadrons. They were then joined by number 20, designate, squadron in May, 1984, who were operating the Sea-Picat Jaguar GR-1 from IF Bruggen. Unlike the tornado squadrons